Okay. All right, chapter 9 notes, properties of radicals. So we're just going to walk through this. Um, Up here, we're going to write some numbers here in a minute. So keep this. If you already wrote your name, we can do it somewhere else. But so basically, what is a radical? You guys know? A radical expression is an expression containing a radical, square root, cube root, whatever. So here's what a square root, cube root. That's square root, right? What number is really right here that we don't see?
2.
2, right? So you don't see it, but there's really a 2 there. Okay? What it's saying is like, if I have 9 in there, just as an example, what it's saying is what number times itself, or what number squared equals 9?
3.
Okay, so square root of 9 is 3. That's what a radical is doing. A radical is breaking down a number into its square. Okay? So what we're going to do today, we're going to learn how to simplify radicals. How to change these from a big number with a sign to a smaller number, either without a sign or a smaller number inside the sign. Okay? So just like simplifying fractions, we did that in the bell ringer. We had 3/9 and we switched that into what? 3/9 became 1/3, right? So just like fractions, simplifying those, we can simplify radicals. We can make them smaller numbers, okay? In order for it to be in simplest form, there's 3 rules. So you want to keep these in mind tomorrow. Rule number 1, no radicands, that means no answers. Radicand is an answer, okay? So your final answer will not have a perfect factor other than 1. So like, this is a perfect square, right? Square root of 9, perfect square is 3. Okay, so you can't have an answer with a radical and a perfect square underneath it, because if there is, that perfect square should come out. All right. This yellow chart, we're gonna do that chart on your paper, so you're not gonna have a yellow chart. We're gonna do that in a second. Number 2, no radicands contain fractions. Okay, so you can't have a fraction in here. We got to solve it. Okay. And finally, no radicals appear in the denominator of a fraction. So if you do have a fraction, you can't have the sign underneath. So I'll go through all that here in a minute. Okay? All right. Let's do this right here. Okay. This is basically what we're going to do the entire day. We're going to solve these radicals. We're going to simplify them using this property right here. All right? So the simple way to say this is square root okay, or yeah, square root of a number can be broken into 2 square roots. One would be a perfect square and one will not be a perfect square. Okay? And I'll show you what that means here in a second. The square root of a number can be broken into 2 square roots, a perfect square and a non-perfect square. Okay, so this is a point. I'm going to do it right here, actually. If you want to do it, wherever you want to do it is fine. But These are your perfect squares. Okay, we're going to list them out. Actually, I'm going to write that a little different. I'm just going to write it smaller so you can see. You'll use this, you need to have this list because we'll use this to simplify these. Okay. Okay. You guys help me out with this. What is 1 squared? 1, right? What is 2 squared? 4. Yep. 3 times 3. 3 squared. 9. 4. Okay. Now we're getting the hang of it. 5. 25. Okay. 7. 49. 8. Okay, so if you know the pattern, keep going. 81. I'm going to try to get to 15. 13, anybody know? 14, anybody know? 225. That's probably as far as you'll need to know for what we're doing. I don't know. I think that's as much as you'll need. If not, you can obviously use a calculator. These are ones, I'm not saying you have to memorize them, but as you keep going, you'll probably see them enough that they might start to get stuck in your brain. I don't know. Okay? So as we solve these, we're always going to have, what are we going to break? We're always going to break a square root into 2 things. Well, yeah. We're always going to have at least 1 perfect square. You have to. Because like if we had a problem down here that just said, what's the square root of 9? What's the square root of 9? 3. Okay, so that would be our answer. You get what I'm saying? You wouldn't have to break it into a perfect and a non-perfect because it's already perfect. So you always have at least 1 perfect. If it's not a totally perfect square, though, that they gave you, then you're also going to have a non-perfect that stays in the radical. Okay? So I'm going to show you what I mean. Here's an example. So they give us the square root of 45. Okay, here's your process. This is the number from the bottom right here, 45s, bless you. So you look, is 45 in this list? No, so it's not a perfect square, right? But there's no number exactly times itself that gives you 45. That's a whole number. Okay, so what we have to do, we have to break it into 2 things. We have to break it, I just write PS, perfect square, and then NPS. What do you think that stands for? You guys are good. Perfect square, non-perfect square. Okay. So our next step is to look at our list of perfect squares. That's why we made this list. Okay. It has to be a number from the bottom. So we look. It can't be past 45, right? So it can't be any of these. So we start here. We look at the biggest number that goes into 45 evenly. Does 36 go into 45? 25. No, because 25 goes into 50, right? Quarters. 16 going into 45. No. Kind of, but does it exactly? It's got to go exactly, okay? It doesn't. Does 9? Right. So 9 would be our perfect square, right? So down here we're going to write square root of 9 times square root, or what times 9 equals 45? Okay, so that goes there. That's our non-perfect. Okay, so we broke it into a perfect square times a non-perfect square. See how here it says like a times b? I can break it into two different numbers. What is the square root of 9? 3. Very good. So square root of 9 is 3. Can we square root 5? Is it a perfect square? No, we can't square root it, so we're done. There's our answer. So we turned a perfect square into the answer. We turned a non-perfect square just into a simplified number. So that would be the answer. The square root of 45 simplified is 3 square root of 5. Crazy, right? Lots of stuff, but I know. So, like, if you did not watch me do this, is there any way you would probably get from square root of 45 to 3 square root of 5? No, because it's like totally crazy, right? Okay, so basically the way we do this, it just takes practice. You just always have to say, I'm going to break this into two numbers, square root one of them, don't square root the other. There's your answer. Okay, so let's move down here. Square root of 108. Okay, so again, we're going to break it into a PS and an NPS.
Can we just divide it by 2?
It won't work because 2 isn't perfect square, right? So you have to find the biggest number that goes into it perfectly that's a perfect square. Okay, so it always has to be divided by 1 perfect square, all right? So does 81 go into 108? No, the easiest way to do this is just calculator, like 108 divided by 64. No. 49. No. 36. It's 108 divided by, divisible by 36. Well, just think about 100. Is 100 going to go into 100? No. 81. What's 8 plus 8? 16. So 81 times 2 is going to be like 160. You know what I'm saying?
Yeah.
Okay. 64 times 2, 6 plus 6 is 12, so that's going to be like 120. That can't go into it. 49, that's close. 40 plus 40 is 80. 9 plus 9 is 18. 80 and 18 is 98. It's 98, not 1. Okay? So that's where I'm saying calculator. Just what you'll do is just get a calculator and just start doing 108 divided by each of these until you see. You said 36 goes into 108? Okay. So what's our perfect square? Which one? 36 or 3? Okay. So 36 goes here. 3 is a non-perfect square. All of these will have one of these numbers that goes into it. Yes. If you ever find one that doesn't, you just leave it. That's the final answer. That's as simplified as it gets. Okay? Like the number 13. Do any of these go into 13 besides 1? No. So it would just be square root of 13. Like that would be the answer. Okay. All right. So we got to finish square root of 36 times square root of 3. What's the square root of 36?
6.
Okay, so 6 and then square root 3.
Not that hard.
Yep, it's not too bad. How come I don't write times right here in the final answer?
Because it's not.
It's like already, if the number's in front of it, you know it's being multiplied, okay? Just like if we had 6x, treat this just like a variable, like 6x.
What do you want?
39. So we got about 14 minutes. Okay, let's try number 2. So you're looking for the biggest number. Goes into 500. Okay? She says 100. Did you try all these?
Yep.
Yep. 225 times 2 is 450. So none of those go into 500 evenly other than 100. So how many times does 100 go into 500? Okay. So this is our PS, this is our NPS. I write it every time just because it helps me remember, but I would if I were you. Square root of 100 times square root of 5 is the same thing as square root of 500, right? What's the square root of 100? 10. And can we square root 5? So there's our answer. 10 square roots of 5. Okay, 3 is trickier, so give me a second on 3. It's close, but that little number in there is going to throw you off. Let's actually skip 3 for a minute. We'll come back to 3 and 6 in a second. Let's look at 4 and 5 before we go to 3 and 6. Okay, I'm going to slide down here. Okay. No, we're just going to go through number 9. Number 9 today is all we're going through, I think. We may look at the fractions if we have a second, but I don't think so. Okay. No, we're not going to do the fractions. Not quite. Too big. So what I would do is look at 5. Are either of these perfect squares? No. Okay. So what we would do is actually work. We have to kind of work backwards. So we're going to multiply 5 times 10, which is what? Square root of 50. Okay. Now you look at your list that you had up there, and which perfect square goes into 50? Remember, it's the bottom number, so 25, right? 25 and 2, because 2 times, you're just figuring out what times 25 equals 50. I mean, all you have to do is take a calculator and just do like 1 squared, 2 squared, 3 squared, you know what I mean? But they won't like give you the list, no. You'll have to come up with it on your own. Yep. I mean, it's like your times tables, right? You guys, like 12 times 12, hopefully. Yep. Okay. So square root of 25 is 5, and can we square root 2? No. So there's our answer. Okay. So some of these you got to kind of work backwards to multiply them back out if these aren't perfect squares inside.
Wait, so what do we do if they are?
Then so if this was like 16, that would be 4, right? And then that would be square root of 6. So 4 square root 6. Okay. So you just.
That's the answer?
Yeah, if this was a perfect square. Okay. Then you would, so let's say this, I'll just write one down. If it was like square root of 16 times square root of 4. What's the square root of 16? 4 times square root of 4. 4 times 2. So that'd be your answer. Okay. So you're basically just simplifying these numbers as much as you can, and then if they turn out to be whole numbers, great. If they don't, then you just leave them as radicals.
So would any equal a decimal?
Okay, that's a good question. It will probably tell you either put it in decimal form or radical form. So if it says put it in decimal form, you would just type in like 5 square root 2 in your calculator and hit enter, and it says 7.1. So that would be decimal form. But usually it'll say leave it in radical form. So since this has a radical, you just leave it like that. Okay. Okay, number 5. Let's look at it. What would you guys do since neither of those are perfect squares? Multiply them. So you multiply 18 times 6 and you get square root of 108. Okay, this is what I was saying earlier. Look at this. Do you notice anything about this that you may have already done?
They equal.
Oh, it's that one.
You get what I'm saying? So what was the final answer?
6,
Final answer.
6.
So if you already have the answer in one place, do you have to do the work again? No. Just, you know what I'm saying? Tomorrow you'll have some work doing these. If you've already done it somewhere else, don't do the work again. Just use what you've already done. Okay, 3 and 6, we're going to have to make a different list. So that's why I wanted to talk to you about that. So this is perfect cubes. So we're only going to write about 6 of these. We're not going to write 15 because it gets really big really fast. So over here I'm going to make a list of perfect cubes. So what's one 1 cubed. 1 times 1 times 1. 1, right? Still 1? It's all right. Okay, so 2 cubed is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So it'd be 8. Okay, that's what I'm saying. They get big fast. So 3 cubed. 3 times 3, 9 times 3, 27. You get what I'm doing? I'm just cubing these numbers instead of squaring them. So 4 times 4 times 4, 64, right? See how big they get fast? 5 times 5 times 5. 125, 6 quarters, or 5 quarters, right? Okay, last one I'm going to try. I don't know if I'm going to be able to squeeze it on there. 6 times 6 times 6 is 216. That's really about as far as you'll probably have to go up. If not, you can always just put it in your calculator. 6 times 6 times 6, 7 times 7 times 7, 343. Okay, so what I'm doing here, we're now looking at a cube. So we're going to break this into a perfect cube instead of a square. It's the same exact process in a non-perfect cube. So we look at a perfect cube that goes into 81. So which of these numbers goes into 81? It can't be 125, so divide 81 by 64. Is it 64 going to 81? Divide 81 by 27. Is it going?
Or yeah, just
How many times?
3.
3 times. So our perfect cube is 27. No, I'm just showing like I'm just taking them. You can do it however you want. So 27 and 3. You get, it's the same exact process, it's just a different set of numbers. Okay, you with me? Okay. All right, so then we would do cube root of 27 and cube root of 3. What was the cube root of 27? 3, right? So we get 3, lots of 3's. 3 cube root 3. I'm going to write it out to the side so you can't see that. Okay, so that's your answer. You're not going to cube root a whole lot. You're going to square root mostly. Okay, so 6, you would do the same thing you did on 4 and 5. So multiply them. So 6 times 12, anybody got that? 72, right? Then you got to figure out what number goes into 72 from your cube root. 8, right? 8 times 9. Okay, cube root of 8 is 2, and we can't cube root 9 because there's no number times itself 3 times, it gives you 9. So that would be your answer, 2 cube root 9. Okay, we're going to do the last 3. What's the difference in the last 3 than what we've had? They have letters. Okay, the variables are super easy. Don't get stressed about the variables, okay? So here's what we're going to do. You always do the same process you've been doing. So perfect square of 49 is what? 7, right? Okay. So perfect square, 49 is a perfect square. So are we going to have a non-perfect square of 49? No, because 7 is the perfect square, right? And then, here, can you guys see that? I'll raise it up so you can see it.
Wait, so we're not using this one, we're using the first set of numbers?
Yeah, now, okay, so we're back, this is a square root because there's no 3 in there. So we're back to the first set of numbers, okay? So, yeah, you'll only use the second set when it says a 3 outside. Okay, I'm breaking this into perfect square and a non-perfect square. Perfect square of 49 is 7. Okay, to square root letters, you always just divide by 2. So x4, what's x4 divided by 2? x2, right? That's actually your answer because it's a perfect square. It's an even number. So that's it. There's no non-perfect square in this problem. So that problem is done. 7x squared is your answer. Square root of 49 is 7. Square root of x to the 4th is x squared. Okay, so that's what I'm going to show you. Okay, so number 8. So again, you always want to break it into perfect and non-perfect. So what perfect square goes into 18? Do the number first. What? 9 times 2. Okay, now we break this into, break x3 into the largest, what's the largest even number next to 3? No, just right, sorry, this side, yeah, 2. So we can put like x2 here and x1 over there. Okay, because you can divide this by 2. You can't divide that by 2. So I broke this into 9 and 2, and then I broke this into x2 and x1. You just bring the even number over here, and then a 1 over there. Anytime it's odd, a 1's always going to come over here. Okay? So now we do the square root. So the square root of 9 is what? So 3. Divide x2 by 2. So x1, right? And then over here, we're left with 2x, because that's all that's left. It stays in. So the non-perfect square always stays in the radical, because you can't square root it. You can't square root 2, and you can't square root x1, because it's not an even number. Does that kind of make sense? So there were 3 of them. So I broke it into 1 over here and 2 over here, right? Split them, and then anytime, like we did here, anytime you square root an even number, you divide by 2. So x4 becomes x2. So like here, I think it'll make a little more sense. So let's break 75, yep, 25 and, okay, and then how many ends can I bring into this one? 6, and then how many ends there? 1, okay? So n6 and 1. Okay, this is never going to change. So once we've got that non-perfect square, like basically it's going right there. And then we just have to figure out what's the square root of 25. Okay? And then divide 6 by 2. And 3. What do you guys think? Can you do it? Okay. I'll make it optional. There are 6 questions on big ideas. If you just want to practice, you can. You don't have to do it. It's not homework or anything. It's just practice for you if you want to try it. You can check your answers, see if you're doing it right. Okay, like I said, tomorrow I won't be here. You'll have a sub. You'll have a worksheet to work on. If you get it done, turn it in the box. Sound good?
Yeah.
I'll be back Friday. Sorry I'm missing.
Friday.
Friday. Tomorrow, it's already Thursday. Guys, we have 7 more Mondays.
Okay.
That's a lot. 7 weeks. 6 more Fridays. Maybe 5. Hey, those people that weren't here, who wasn't here? Trey, Brody, can you guys kind of help them tomorrow? Just let Carson, you guys give them a little heads up. Izzy, Sabian, can you help Izzy tomorrow if she's here? Really? She's sick?
And I just quit school. I have a job this summer.
How do I? Did this record?
Oh, you click the stop button.
Where at? Oh, right there.